Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Now, in this video, we will talk about proof technique and conclusion. Have you already learned about this material? But before we start, let me introduce myself. Hello everyone, my name is Amanda Fifi Mahe. You can call me Amanda. My name is 4101422097. A mathematical proof is an inferential argument for a mathematical statement, showing that the state's assumption logically guarantee the conclusion. Do you know guys have many methods to prove? So many different methods of proof. Method of proof, the first one is direct proof. The second one proof by mathematical induction, proof by contraposition, proof by contradiction, proof by contraction, proof by exhaustion, probabilistic proof, combinatorial proof. But in this video, we specially chose to talk about direct proof and proof by mathematical induction. Direct proof. In a constructive proof, one attempt to demonstrate P implies Q directly. This is the simplest and easiest method of proof available to us. There are only two steps to a direct proof. The second step is of course the trial part. The first step assumes that P is true, and then the second step is use P to show that Q must be true. And then the next topic is example for direct proof. In this slide, we have problem. If A an odd number and B an even number, then 5A plus 2B squared plus 1 is even. Proof with the direct proof. From this statement, given A and odd, so it can be defined as A equal to n plus 1 for n element integers. B and even, so it can be defined as A equals to m for m element integers. So we will prove a P equals 5A plus 2B squared plus 1 is even. The proof is P equals 5A plus 2B squared plus 1, and then we substitute A, so we get 5 times 2n plus 1 plus 2 times 2m squared and plus 1. We operation, so we get the 2 times 4m squared plus 5n plus 3. By just T equals 4m squared plus 5n plus 3 for k element for integers, then P equals to k. Since k is an integer, it can be concluded that P equals 5A plus 2B squared plus 1 is proven to be an even number. The next topic, we will talk about proof by induction. Proof by induction is a very powerful method in which we use recursion to demonstrate an infinite number of phase in a finite amount of space. The most basic form of mathematical induction is where we use frequent proportional from whose truth is determined by an integer function. If we are able to show that proposition from is true for some integer value, then we may argue for that basis that the propositional from must be true for all integers. The step for proof by induction is the first one, so that a propositional from Px is true for some basic case. The next step is assume that Pn is true for some n, and so that this implies then Pn plus 1 is true. And then the next step, then by the principle of induction, the proposition from Px is true for all n greater or equal than the basis case. Next, we have example for the proof by induction. So that we have a problem proved by mathematical induction that 2 power 3 plus 4 power 3 plus 6 power 3 until plus 2n power 3 equals 2n power 2 times n plus 1 power 2. So the step to prove is suppose Pn so that 2 power 3 plus 4 power 3 plus 6 power 3 plus until 2n power 3 equals 2n power 2 times n plus 1 power 2. Step 1, Pn true for n equals 1. So P1, then we get 2 times 1 power 3 equals 2 times 1 power 2 times plus 1 power 2. So we get equals to power 3 equals 2 times 2 power 2. So we get A equal A. So it must be true. And we're going to step 2. So please make k true for a natural number, then 2 power 3 plus 4 power 3 plus 6 power 3 plus until 2k power 3 equals 2k power 2 times k plus 1 power 2. This must be true. So we saw that pk plus 1 is true. Then we calculate that 2 power 3 plus 4 power 3 plus 6 power 3 until 2k power 3 plus 2k plus 1 power 3 equals 2 times k plus 1 power 2 times k plus 2 power 2. And this sound as follow 2 power 3 plus 4 power 3 plus 6 power 3 until 2k power 3 plus 2 times k plus 1 power 3 equals the same went to the right side, so equals 2k power 2 times k plus 1 power 2 plus 2 times k plus 1 power 3. So that we will calculate like in this slide and we get 2 times k plus 1 power 2 times k plus 2 power 2. So 2 power 3 plus 4 power 3 plus 6 power 3 until 2k power 3 plus 2 times k plus 1 power 3 equals 2 times k plus 1 power 2 times k plus 2 power 2. That mean k plus 1 is true. So Pn is true for every natural number of n. And then the next topic we will talk about conclusion. So in this case we have the problem Jenny will be at the park if Mike is there and Billy isn't there. Mike will be at the park if it's on Saturday or Sunday. If Billy is at the park, TY will be there. TY won't be the park if it's on Saturday. The park is on Saturday, therefore Jenny will be the park. So the solution is let J stand for Jenny be at the park. M for Mark will be there. B for Billy will be there. T for TY will be there. R for the park is on Saturday. And S for the park is on Sunday. Then this argument that they has the form M and negation B implies G. R or S implies M. B implies T. R implies negation P. So R. So we conclude that with G. So from the premise before, the step 1 is R implies negation T is premise. 2 R premise. 3 negation T we get from 1 and 2 modus ponens. Step implies T from premise. The step 5 negation B from 4 and 3 modus tollens. And step 6 R or S from 2 addition. The step 7 R or S implies M from the premise. And the step 8 we get M from step 6 and 7 modern exponents. And the step 9 we get M or M and negation B from A and 5 conjunction. And step 10 M and negation B implies J from the premise. And the step 6, 7, 11 from the 11th step. So we get J from 10 and 9 mod exponents. So we prove that J. So the material for in this video. Thanks to watching. I'm sorry. I'm apologies for any mistake for me. So thank you and see you next time. Bye bye. Wassalamualaikum warahmatullahi wabarakatuh.